slides. Once those slides are, oh, sorry about that. Okay, so we are recording it tonight, and once we've done the recording and the slides, will then go on to our microsite, so you anybody who missed it can then see it. The meeting will be locked in about 10 minutes, so we don't have any stragglers coming on, but please come. Any questions you put in the chat function, we will collate and ask Mary after you've done a talk. I'll give you a quick information on branch news updates, IOSH news and updates, and then we'll have Mary doing a talk on welding fume and metalworking fluids, and then the Q&A will be done by myself and John Jones, my vice chair. Okay, so branch news and update. So our next meeting is on the 19th of August at 6:30. It's TG20 Scaffolding Standards Explained, and that'll be done by Simon Hughes from Simeon Risk Limited. That should be really interesting, and maybe worked with other regions, either South Wales or West Wales, but really getting all the branches involved in what we do. And then on our September meeting, the 16th of September, is on how to do a suitable and sufficient L8 Legionella risk assessment. And that's from Carl Hughes from M&S Water Services Limited. This will give you an idea of actually how to do a Legionella risk assessment, like we did for fire risk assessments last December, which was very welcome. And I think a lot of people wanted to watch that one as well. Okay, a bit of update for you on IOSH update. North Wales are in a region with Paul Council, our regional manager. So we share it with West Wales, South Wales, South Midlands, Merseyside, Isle of Man, and Bristol and West. And presently, what we're trying to work on is a group of talks that hit all the standards within the new membership grades, but also provide a good overview of all aspects that meet those criterias, which I think is really useful. And also it gives us the opportunity to look at, if we're doing a talk on, if one of the groups is doing a talk on law updates, we can all click into that one as well. So it's a way of improving the service we give you and improving the members' experience. Okay, changes in membership grades, again, are still waiting Privy Council approval. Once that comes through, we will know directly from IOSH HQ. Okay, so today's discussion topic is hazards from welding fume and metalworking fluids. The speaker is Mary Cameron, who's the Occupational Hygiene Technical Manager at EUK. As I said before, any questions, drop them in the chat function, and then we'll ask Mary at the end of her talk. So what I'll do now is I will stop sharing and I will pass you over to the capable hands of Mary Cameron from EUK. So hello, Mary, and over to you.
Excellent. Thank you so much. So I'll do a screen share of my PowerPoint now. I'll turn off my video just in hopes that my audio comes through a little bit quicker. So just give me 1 second. Oh, screen share. And bear with me, I'm sorry, I'm not very techie. Up to the top. Right, can everybody see that okay?
Yes, we can.
Okay, great. Okay, I'll dive right in. If my audio gets sketchy or anything, just interrupt me and I'll stop. So yes, here we go. Okay, so thank you so much for having me. I'm Mary Cameron. I'm a certified occupational hygienist and Occ Hygiene Tech Manager at the EUK Group. And I'm going to be talking about all things welding fume and metalworking fluid. I'm so happy to be presenting. This is actually, it's kind of strange for me because normally I'm the one putting the webinars together. Normally I'm the Richard and not actually presenting at them. I represent the British Occupational Hygiene Society for their own regional meetings for the Midlands. The BOHS is much like IOSH. We run webinars on a huge range of alcohol hygiene related topics. If you are interested, please do check out the BOHS website for their membership information and events calendar. We have all sorts of fun webinars, just like IOSH does. Right, so diving right in, the HSC announced earlier this year that they intend to send their inspectors to fabricated metal businesses between May and September of this year. So this is now underway. These inspections are aimed to ensure duty holders know the risks, plan their work, and have adequate control measures in place to protect workers' health. When organizing this presentation, I thought, okay, welding fume and metalworking fluid, these are such big, complex topics. How am I going to break this down? Well, I'm going to do this how I know how to do this as an occupational hygienist. Occupational hygiene is concerned with the anticipation, recognition, evaluation, and control of health hazards in the workplace. The focus of an occ hygienist is worker health protection. Did you know, perhaps you probably do know, that for every one safety-related death at work, there are about 100 health-related deaths from work-related disease. It's really shocking, and this is why I focus on occupational health is so important. So I'll be going through each topic, taking the step-by-step approach as an occupational hygienist, and I'm going to start first with metalworking fluid. So, okay, first things first, anticipation. This is the recognition of hazardous conditions. So metalworking fluid, what is it? It is the name given to a range of oils and other liquids that are used to cool or lubricate metal workpieces when they're being machined, ground, milled. There are 4 basic classes. There's straight or neat cutting oils, which can be made up of mineral or synthetic oils, which have been refined and are not diluted by water. There's soluble oils containing refined petroleum oils and emulsifiers. There's semi-synthetic fluids also containing refined petroleum oils to a lesser extent, as well as water and additives. And there's synthetic fluids, which do not contain petroleum oils, but use detergent-like components and other additives to help wet the workpiece. So those are your basic metalworking fluids. When we go to site, we will see containers of metalworking fluid like this. We could be dealing with a neat mineral oil, a water coolant mixture, a petroleum-based distillate, vegetable oils. It totally depends on what is the process exactly that metalworking fluid needs to do. So what we really need is the safety data sheet, the SDS, to assess what exactly this metalworking fluid is. But we can't just stop there. The SDS doesn't tell us everything. This fluid can have additives. It can have biocides, contamination of oil or metal fines. These things, it changes the nature of the contaminant. And as this process is a high energy process, it creates a mist. This causes the fluid itself, as well as these contaminants within the fluid, to become airborne. Right, so we know what it is now. Next is recognition. This is the identification of hazards and their adverse effects. We've reviewed the SDS. We've looked into contaminants and additives. How hazardous is this fluid when we then generate it into a mist? Well, the health risks associated with metalworking fluids are thought to be from a microbial origin, so the presence of bacteria and endotoxins. The focus should therefore be on the root of this exposure, which is a poorly implemented fluid management system and inadequate controls. A poorly managed system will likely lead to increased microbial growth, and inhaling contaminated metalworking fluidness can cause lung disease, such as hypersensitivity pneumonitis and occupational asthma. It can cause skin disease, such as dermatitis. But the health risks can be managed should the composition of the fluids be prevented from deteriorating whilst in use. As the fluid contamination and as the fluid contaminates and the conditions are in favor of microbial growth, this increases the health risk. Okay, next, evaluation, the measurement of exposure to hazards and the qualitative or quantitative interpretation of those hazards. This is a little bit of a pet topic of mine, so forgive me, I get a little excited here. But before we actually go straight into personal exposure monitoring via sampling, let's first look at the ACOP of QUALITATIVE Reg 10, which is about monitoring. Ask yourself, do you need to monitor? We do if the points seen here on this slide are met. But we should also really be keeping in mind there is an HSC monitoring strategy for toxic substances outlined in a document called HSG 173. It details at what point measurements would in fact be needed. There's quite a bit you can really do just by an initial appraisal and a basic survey using qualitative or semi-quantitative means of assessing the exposure. So it's just to say you don't necessarily need to dive straight into sampling. But let's say we meet these points I just showed you, and we do need to measure personal exposure levels. How do we sample? Well, this is a loaded question. Here are a list of some options. I've made a table of pros and cons listed out for each of these methods. If anybody wants to see a copy of this table, just send me an email. I'd be happy to share it. It's just far too detailed for this presentation. But essentially, these methods all come with their own advantages and disadvantages. So NDHS 84, for example, it's a gravimetric analysis with further extraction option for cyclohexane soluble material. This can take out deposits from potential interferences. The cons to this method, though, is that it's only valid for neat mineral oils, and they really need to be highly viscous. It can underestimate concentrations of the oil as low viscosity. It basically volatilizes, evaporates basically right off of the filter if it's low viscosity. Another popular method is NDHS 95. This is for your water mix, metalworking fluids, your coolant water mix. And it uses a marker element. So taking a personal sample via the IOM head and you analyze it against a liquid sample from the CNC machine, the sump and the neat coolant and the water supply sample. We can then work out the personal exposure based on the percent dilute of the water coolant mix. But, and this is a big but, you need either boron, sodium, or potassium present within the coolant to act as the marker. Normally it's boron. Saying that though, boric acid has been recently classified as a substance of very high concern. It's a potential human reproductive toxicant. So lubricant manufacturers have sought alternatives and developed miscible metalworking fluids without or with reduced content of boric acid. Therefore, boron might not even be present or in high enough concentrations to be used as a marker for this method. And it really throws a kink in the works for that one. So I'm talking about quantitative methods, but I just want to sidetrack for a minute because let's say we do undertake the sampling. What do you compare that result against? It can be really difficult to judge the risk without limits available, and there is no workplace exposure limit for metalworking fluids. There's some possibilities. So there's a NIOSH REL of 0.5 for the total particulate mass. It can be applied, but with caution, as this is not a health-based limit and it may still result in ill health. There is also a withdrawn guidance value of 1 for water-based metalworking fluids. But again, this is not a health-based limit and was previously defined as a good practice control level. Furthermore, outbreaks of lung disease have occurred under this level, and so it is not a safe limit. If we are to ever reference a revoked limit or a guidance limit, then we just need to be very, very clear that it is not being used to judge acceptability. And let's not forget a LARP. It's not just about the sample result being below the well or guidance limit. No matter the sampling result, it is vital that the principles of good practice with hazardous substances are applied. And due to the severity of the diseases that metalworking fluid may cause, and that there is no safe exposure limit, the level of control needs to be high. And this broadly equates to a LARP. I talked about a couple of more popular sampling methods. There were several others which I had listed as options, but those were your quantitative means of measuring exposure. I want to now talk about the qualitative means. So here we have a DRAM. A DRAM is a handheld direct-to-read aerosol monitor. This provides a quick means to assess changes to the concentration of your metalworking fluid mist, albeit just relative changes. It's not suitable for actually quantifying measurements of the mist. There's also a Tyndall beam, which is essentially a dust lamp. This dust lamp highlights aerosol particles not seen with the naked eye. And a smoke generator, fake smoke generator, allows visualization of airflow movement within or around the machinery. These evaluation methods can help inform decisions regarding where to focus investments to improve exposure control measures. Right, so saying that though, I've talked about, your qualitative, and I am personally quite a fan of the qualitative. There may still be cases where active personal sampling is required. For example, should further data be needed to make an informed decision regarding the likely exposure levels? Like, should it not have been practicable to gather sufficient information during the fluid management audit or qualitative analysis? Sampling can be done, but I caution that these sampling methods each have notable limitations. And what is sampling really even telling us? That, the gross stuff in the air is coming from the CNC machine. Well, we likely already know that. And a qualitative assessment would be able to highlight those control failures more readily. So, going back, right, so now that's a lot of different ways to assess metalworking fluid exposure. We have quantitative, we have qualitative. Which one should we pick? Well, this is my personal opinion. I've already hinted at. So the lack of health-based exposure limits to base the sampling results against is a considerable drawback to quantitative sampling approach. The sampling methods themselves have many drawbacks. They give you fuzzy numbers to work with. And I feel that a quantitative approach may take attention away from what is most paramount, and that is actually controlling the exposure. So the focus should be on control. Mitigate the risk by properly managing your fluid quality, control the mist generation at source, and prevent direct contact with the fluids. I would advise that the most constructive approach to evaluating the risk to metalworking fluid exposure is auditing the fluid management system along with a qualitative analysis of the exposure controls in place. Quantitative sampling can provide the employer with some evidence about the adequacy of the control measure, but this must be complemented with observations made during the qualitative analysis anyways. And also the achievement of adequate control being decided in line with the requirement of work, not just sampling results. Okay, so yes, a qualitative assessment backed with an audit of fluid quality management program in place. That's my vote there. I've talked about the former already. I want to talk about the latter now. Fluid quality management auditing. There's a guide from UKLA, that's the UK Lubricants Association, called Good Practice Guide for Safe Handling and Disposal of Metalworking Fluids. There's also the HSC's COSH Essentials from the MW series. In particular, MW5 goes through managing your fluid quality. These are excellent sources of information on how to properly manage your metalworking fluids. But say if we go in and we're actually auditing this system on site, here's a list. It's not an exhaustive list of what we would want to review during an audit. So you'd want to be asking questions like, is the concentration maintained as it in line with manufacturer's instructions? Are changes in appearance, are odor apparent? How about the water source quality, pH levels? Are there oil leaks and contamination? Is there foaming, biofilm, stagnation? Are they using the biocides correctly? What's the temperature? What should it be? Are there signs of microbial growth? What's the cleaning procedure? So all this really needs to be looked into. And as I've just mentioned it, so I'm gonna sidetrack just for a sec. The COSH Essentials for Machining with Metalworking Fluids. This is the MW series. It's actually very recently been updated. And what you see here, this is what I've done, is I've cross-compared the recent version to the older 2011 and 2016 versions. I do apologize, it's a little bit blurry. But I'm really impressed with how robust the new MW series is. In particular, yeah, for MW1, there were a few key differences in this latest version, which stood out to me against older versions. So for example, they've highlighted the hazard from the escape of mist when the CNC doors are open too soon after machining stops. And having spent years as an hygienist going into these manufacturing facilities with CNC machines, the operators, they'll do their milling cycles and they open that door right away, right after the milling, like the second when the milling stopped. And the mist is still in there, and they're basically just whooshing that mist right out into their faces by opening that door too soon. So I was very happy to see in this update that they've highlighted that, don't open your doors too soon. Allow the extraction to take that mist away and then open the doors. So that was a very good point added in. They've also highlighted in this new update controlling the skin risks as well as the respiratory risks, enclosing machines by retrofitting roof panels, stating the method for determining the time delay on the enclosed machinery. So what I was saying about don't open the doors too soon. They talk about alternative methods to cleaning components via air guns. Air guns should definitely be avoided. They resuspend that subtle fluid. And they talk about there's a better definition of a competent person when it comes to LED system documents and testing. And one thing that really stood out to me is measures to check the effectiveness of controls are noted, such as a dust lamp or a dram, what I was just talking about, and monitoring the fluid quality. It doesn't mention air sampling. The previous versions did, but I noticed in this update, there was no more mention of air sampling. So I thank you, HSC, you're backing up my flag waving for the qualitative assessment there. And then they also went a bit more into health surveillance for dermatitis and backed it all up with information instruction and training and how important that is. So really, just a really good update. I was very impressed with this. Right, okay, so controls. We've done evaluation. Let's go to the controls. This is the process of conception, education, design, and implementation of beneficial interventions and changes carried out that eliminate, decrease, or downgrade the hazardous conditions, right? So how do we do this for metalworking fluid mist? Well, of course, let's take a look at the hierarchy of control. All those listening will be, of course, familiar with the hierarchy of control. But let's, because we're so familiar with that, let's just go straight into some specific controls for metalworking fluid. Mist control measures may include enclosures, like retrofitting the roof panels, applying the fluid at the lowest possible pressure, personal decontamination and good skincare, good housekeeping, fluid management, incorporated mist filtration extraction units, so your LED, good working procedures. So for example, avoiding the use of airlines to blow down the components and employing instead vacuum guns, absorbent materials, spindle mounted fans, or automatic compressed air hoses within the CNC enclosure, as well as the programmable delays in opening the CNC enclosure too soon. I have a bee in my bonnet about the operators opening the doors too soon and getting a face full of mist. And it's also crucial that information, instruction, training for the workers is provided in relation to the risks and controls. A review system for the effectiveness of these controls is also essential, as this will trigger prompt remedial actions when required. And health surveillance program. This may be needed if there's a reasonable likelihood that asthma may develop due to regularly inhaling metalwork fluidness. We're getting towards the end to metalworking fluid. A couple more slides. So with the HSC inspections underway, inspectors will be checking that businesses are complying with the guidance to manage the risk of respiratory diseases in regards to metalworking fluid. Such guidance is available through the COSH Essentials I was just discussing, the UKLA guidance I was also just discussing. There's also INDG 375. There's HSC's operational guidance 109. These resources provide tools to help businesses ensure they have the necessary measures in place to protect. Right, in summary, how could I have possibly summarized metalworking fluids so quickly? I don't know, but because it's such a loaded topic. So in summary, we need to anticipate, recognize, evaluate, and control the health hazards. Know your fluids, look at the SDS, but also at the source itself. Look for signs of contamination or additives, which can affect how hazardous the metalworking fluid truly is. The latter points would not be covered in the SDS. And because these fluids are being used continually, the composition is changing, the concentration changes, metal fines and oil may build up, microbial growth may form as if the fluids are not being managed well. This changes the composition, and it means that it changes the extent of the hazard as well. So we need to look into it carefully beyond the SDS. We need to know these, for metalworking fluid, they are quite severe. So, and they're especially severe if the fluid isn't being well and the bacteria builds up, contamination increases. And we may need to evaluate it by monitoring. Well, each method, it has its pros and cons. Personally, I would normally not sample unless there's a specific, situation where it's needed. And I would typically go with a qualitative approach backed with a audit of the fluid quality management system in place. From there, we need to control the exposure and then review your controls. Continued effectiveness of the controls is so, so important. And I don't know if anybody wants a breather at this point, because now I'm gonna hop into welding fume, or do you want to stop for questions or allow me a second to breathe, or what would you like?
Mary, if you just want to continue,
yeah,
and we'll
okay.
do the questions right at the end once you've finished.
Okay. Sip of water and I'm good to go. Right. Okay, that's fair enough. Let's go straight into welding fume. Okay, so yes, as if that wasn't enough of metalworking fluid, we now have welding fume to cover. And I was a little bit selfish. I focused a little bit more time on the metalworking fluid. It happens to be a pet topic of mine at the moment, but there's still time. So let's get into welding fume. Okay, so approaching this again as an occupational hygienist, let's start with anticipation. What is it? Well, welding fume is very complex. It's a mixture of particles, vapors, gases, which arise from the thermal manipulation of metal materials. The fume particles formed from the vaporization of molten metal, and they also give off byproduct gases and vapors. Recognition. Let's now identify the hazard and its adverse effects. Welding fume inhalation may cause a wide range of adverse health effects. Welding and welding on plated, galvanized, or degreased metals may cause additional inhalation exposure concerns beyond just the welding fume itself. And I'm sure we're all aware that in February 2019, the HSC published a bulletin entitled Change in Enforcement Expectations for Mild Steel Welding Fume. And they also released detailed guidance for employers in November of the same year. IARC volume 118. So this notes that there is sufficient evidence in humans for the carcinogenity of welding fumes. Welding fumes cause cancer of the lungs. And they've also, in this research document, stated that there's a positive association between cancer of the kidneys. So it could also be kidney cancer caused by that. There are those are the effects of inhalation, but depending on the job specific circumstances, physical hazards should be considered as well. You could have heat stress, EMF exposure, noise exposure, and IARC 118 I was just talking about, it also notes that there's sufficient evidence in humans for their carcinogenity of UV radiation from the welding. So the UV radiation can cause ocular melanoma, eye cancer. So it's not just the fume itself, but there's lots of hazards that have to do with welding. Right, so welding fume inhalation, it's long since been understood to be hazardous to health, even before this HSC announcement classifying the mild steel welding fume as a human carcinogen. Welders, they're going to be more prone to lung infection, reduced lung function. They may experience irritation of the throat and lungs. Welders may also experience flu-like symptoms after welding. This is called metal fume fever. It's usually linked to welding on galvanized metals, also mild steel. Adverse health effects from exposure to manganese may include neurological effects similar to Parkinson's disease. The well for manganese actually just lowered because of this, this association. Welding stainless steel can produce hexavalent chromium, or chrome 6 you could call it, which is a lung carcinogen. The stainless steel fume, it can also contain chromium oxide and nickel oxide, both of which can cause asthma. Iron is present in most forms of welding fume. It's, welding on steel. It contains iron, of course, and this may cause siderosis, which is the deposition of iron oxides in your lung tissue. Also, the byproduct gases from welding onto degreased surfaces can produce phosgene, which is a toxic gas. Shielding gases can be asphyxiant, confined space, or very poor ventilation. Other gases like ozone and oxides of nitrogen can also be produced, and these are irritants and blood poison. So, yeah, good grief, right? It's incredibly hazardous stuff, welding fume. And next, evaluation. So I went through the whole HSG 173 earlier, but if deemed necessary, we can undertake personal exposure sampling. Following the HSC's MDHSs, so those were the methods for the determination of hazardous substances, we have a few options, which it depends on the situation and the aim of the survey. We typically would sample with an IOM head to measure the inhalable fraction of the particulates and metal compounds within the welding fume. We may also like to sample for respirable fraction, just because, okay, so the wells for the metals in your welding fume, such as iron, cobalt, chromium, nickel, those wells are set for the inhalable fraction, but metals such as manganese and aluminum, which may also be in your welding fume depending, those have wells for the inhalable and the respirable fraction. So to cover for the respirable fraction, we can use either a cyclone head, that's the second in that you can see there, or an IOM with a puff insert, so that's the third in. Some hygienists, though, they avoid IOM heads and cyclone heads altogether and undertake sampling via a face level sampler with a Swinix head. And this is worn on the worker's ear or can be attached to their glasses. And it's worn actually under the welding visor or under the full face RP that the operator might be wearing. I personally, I would go for this Swinix option with face level sampler, just because having been to so many metal fabrication sites, again and again, I was seeing that the welder kept, they'd have all this the visor on and the air fed respirator on, and they kept lifting their mask too soon. They would weld and then want to lift their mask to look at their welding point to inspect it, right? And I found it a bit frustrating because it's like, no, the point of the RP is to protect you, right? If you lift it away from your face, it's not protecting you anymore. So for me, I quite like having the face level sampler, perhaps in addition to the IOM head. But then that way it's taken into account that fume right next to their face, right next to their mouth, right there. And that is, if they're lifting their mask, the RP all the time, again and again, that is showing that fume actually getting to their mouth and their nose still. So just my personal preference, but it can be a little bit debated. Right, so enough about sampling. Let's move on to what we should really be focusing on: control. As always, start with the hierarchy of control. Look at elimination. Do we have to weld? Can we use brackets or fasteners to join the metals together? Adhesives can be considered as well. Although, just to say about the adhesives, you want to check out the hazardous nature of the adhesive. Obviously should be assessed. You don't want to just replace one risk for another risk, right? You want to lower the risk. And some adhesives out there are quite nasty. Let's say that elimination isn't possible and we have to weld. Can we choose a welding method that produces least fume? Like TIG welding produces much less fume than stick, which is your MMA. Can we limit the duration of welding? Can we train the worker to not lift their visor or RP too soon after welding if the welding fume is still rising, which was a bee in my bonnet I was talking about earlier? Can we change the worker's positioning over the fume source? Can we choose alloys and consumables with the least hazardous content? Right, so go by the hierarchy, and sometimes we do end at the bottom of the hierarchy, and often you do need the RPE. So if needed, there are numerous types of RPE that welders can use, provided that the appropriate filters with the assigned APF are at least 20. Power respirators with an integrated welding visor are generally considered the most suitable for welding, particularly for periods of an hour or more. These do not rely on that seal, that tight fitting, face to mask seal, and the tinted visor can be raised without lifting the clear window, allowing workers to inspect the weld without being exposed to the lingering fumes. Great, that solves my problem there. When selecting RPE, be sure to work closely with your PPE supplier to purchase the best type of RPE for your specific situation. So that choice has to be made in line with the risk assessment. The one I'm showing you on the left here is just to give you a visual. There are types of RPE with these visor combos, and this one you can see on the left, you can lift up that visor, and underneath will be a clear window to be able to inspect that weld right after you weld. So you're not just lifting the whole RPE up, like I've seen many a times, very frustrating, exposing yourself to welding fume. What was the point of the RPE? But anyways, and also, I was talking about the ocular melanoma earlier from the IARC report, just to be sure that that visor does have UV protection. And on the right here is the BOHS's Breathe Freely campaign. They have a whole website full of guidance for welders, just absolutely tons. And I've just put here a snapshot of the RP guidance, which goes on and on about different types of RP suitable for welders. Okay, so, and there's just, as I was saying with Breathe Freely, there's just plenty of information available to help employers understand the risks and how to choose the right controls. Here's, I've listed several here, which could be your go-to. So Breathe Freely. And I just wanted to focus on a couple of these guidances in particular. The first being the COSH Essentials for the WL series. So that's your Welding Fume series. WL3, I've taken a snapshot of it here. This offers guidance on good control practices laid out here in this table. So you might have, it totally depends on your scenario. You might be doing, sporadic low intensity MIG welding or TIG, or you might be doing regular high intensity stick welding. And this is just a guide. Obviously, the choice of your control should be made in line with the risk assessment for that exact process for that specific circumstance. But this is just a really good guide to give you, a ballpark team of okay, if you're doing high intensity stick welding outdoors, okay, so that's RP where LEV is not reasonably practical. So it just points you in the right direction. It's a really good good guide. And then the second thing I wanted to talk about, it stems off of this Breathe Freely website I keep going on about. They have a Breathe Freely welding fume control selector tool, and it's great. You launch the tool, click on it, you select the type of weld, the material, the duration, the size of the workpiece, and it spits you out a control option. And I've done on the right hand side here, I've just done snapshots of extraction tables and on tool extraction or PE. It'll tell you which one is most appropriate for your situation you have. But again, it is sure to, of course, undertake a suitable and sufficient risk assessment and choose the controls most appropriate for that situation. But this is just a really good guide to point you in the right direction. LEV as well. So when selecting LEV, there's a lot of guidance you can get from ILEV. That is the Institute of LEV Engineers. And if you go to their technical note, WF01, I've done a few screenshots of the document here. This goes through LEV buying options. Yeah, so here I've just done snapshots of a breakdown of their guidance of individual LED types. You have tool, movable capture hoods, benches, welding booths. The design and installation of suitable LED systems, I have to say it is a job for professionals. So I would recommend highly contacting organizations such as ILEVI for guidance on how to select a competent LED designer. Don't just get any Joe. And we're nearly at the end. Gosh, that went fast, my goodness. So just to summarize welding fume, it's carcinogenic, along with a wide array of other potential health effects. It must be controlled to a high level. This may very likely need LEV and RP also, could potentially be required. And it's important, really, train your workers on how to use these controls and ensure that the controls are being properly maintained for continued effectiveness. And that's it. I'm done. Any questions?
Okay, Mary. If you want to stop sharing your screen.
Yeah.
Okay, we've got a couple of questions for you.
Oh God, I'm so sorry. I'm not very techie. How do we stop?
So just go to, yeah, well done.
I'm sorry, I found it.
Okay, so we've got a couple of questions for you. Okay, from Nick Jones. Is welding fume a bit of a misnomer? Surely cutting would create similar hazards. So should the risk be termed hot works, or is there a major difference between welding and cutting in terms of health hazard?
Do you mean like mechanical cutting or plasma cutting?
I would say you're looking at cutting using, well, could be cutting using a oxyacetylene, I would expect.
Yeah. Yes, so that would be covered as well. That's it. You're thermally degrading that metal alloy. That's going to create a cloud full of your iron oxides, your chromium, your nickel, and your cobalt. It totally depends on what that alloy is made out of. But yeah, so cutting, you definitely still generate that metal fume. With welding, if you are using consumables, just to say the consumables can give off quite a bit of metal fume as well. I'm just thinking in particular, with MIG, you can have manganese in that consumable, and that manganese I was talking about can cause that Parkinson's type ill health effects. So it does depends on the situation, but yes, if you're cutting it, plasma cutting, oxyacetylene, it is creating that metal fume, and that is the hazard. Your chromium is your carcinogen, your iron is your siderosis, your nickel is your asthmagen. It's still could potentially be in that fume cloud.
Okay. Do you find that a lot of companies asking you to do work with welding fumes at the present moment? Any monitoring on welding fumes?
Yes, quite a bit, and metalworking fluid. We've had quite a few customers lately. I'd say, oh gosh, I mean, even before these HSE inspections came about, I was doing it quite a bit before. Perhaps a bit more so now. Yeah, it has picked up.
Okay. And how do you, let me say, from a point of view, the Bosch, BOHS,
BOHS.
What work are you doing with them at the present moment?
Oh, I mean, like personally, or just in regards to like
just with what you're focusing on at the present moment? Oh,
I see. Oh, well, oh God, they have about 20 different things going on at once normally. So, I mean, gosh, there's a whole lot coming out about coronavirus, of course, but I'm just thinking if there's anything specifically they're working on with, I know we have been talking about, I'm actually on the board of BOHS, and we were talking about metalworking fluid, like creating a technical guidance note, because BOHS does create these guidance notes now and again when there's a hot topic such as this comes about. So yeah, do keep your eyes peeled. I think it is in the pipeline there, so it should be coming out to help guide. But I mean, there's so much guidance already. I've talked about, there's absolutely tons and tons of it, Breathe Freely and HSC and UKLA and all sorts. But yeah, BOHS is very onto these hot topics, literally hot topics, welding.
Okay, have you can I ask about being a bit more, have you been to welding sites where they've either been very good or very bad? And give me a very bad, so don't name anybody, but has there been any bad sites you've been to and you found, what issues have you found there?
Oh my goodness. I would say typically the capture hood positioning is such a major thing. A lot of sites I go to where they have welding, they're welding, they're creating welding fume. A go-to quite a bit is that movable arm, the capture hood, like you're
the need of an arm, yes.
And yes, that's, oh gosh, they're everywhere. And
okay,
it is just so user site the other day. I won't name names, obviously, but they're welding here, and you would think they put their capture hood, about there within 20 centimeters or so range. It was about over there, and it was doing absolutely nothing, and it was just driving me a bit nuts. So,
okay, but talking about RPE for welding fume, do you see? I mean, you mentioned a bit about. Do you find that most operators are compliant with using their RPE, or are they a bit lackadaisical?
You know what? I'm pretty compliant. Yeah, I've seen, gosh, at least the last dozen, metal fabrication sites I've been to, they had some sort of LED in place. Perhaps it was these capture hoods and they weren't so great, but very rarely I've been to a site and it wasn't some form of RPE now for welders. I mean, maybe I started in knock hygiene about 7 years ago, and I remember people just welding away just with a visor. I mean, you have to wear the visor, right? But 7 years ago it wasn't so much RP, but I'm seeing it more and more. With I showed you guys that picture of the RPE, the full face papper,
yes.
with the visor combo. Yes. Those are so accessible now, and the technology is just getting better and better around them. They're getting better and better makes. So, it's the future's bright. I'm seeing a lot of it.
Okay, and what would you advise from I can talk about health surveillance for a welding company doing a lot of welding. What would you advise them on health surveillance they should have in place, both for metal working fluids and for welding?
Oh gosh, so I will answer this as best as I can. It's a little bit more of a question for an occupational nurse or health physician, but I would definitely direct you to COSH Reg 11, because that goes over all things health surveillance. But I mean, with metal working fluid, you're gonna have potential for dermatitis, asthma. Those most definitely, I mean, it depends on the risk assessment, but I would say very, very, very likely the risk is going to need to be looked at through a health surveillance point of view. And same with welding fume. You can have aspergens in there. You may need. It depends. This is why I need to be an occupational nurse, but it can be something as simple as a questionnaire. It could be something as high as spirometry testing. And I would say, because of metalworking fluid and welding fume, that the risks are so high, it is likely that you do need the spirometry testing. It is likely that you do need the skin surveillance testing and beyond a questionnaire, but it's really dependent on the situation. If they're just welding, once at a blue moon versus all day, every day, that's a whole other ballpark of, different worlds of risk there. But it depends is my answer.
Okay. Many years ago, they used to complain about metal working fluids where engineers used to put rags covered in metal working fluids in their pockets. Yes. And then we had cancer of the scrotum. But I think that's hopefully that's no longer the issue nowadays.
I did hear about this as well. I think it's less and less so, because the oils back then were more unrefined.
Yeah.
And they were a higher hazard, I think. And also nowadays, these operatives know not to put dirty rags in their pocket and contaminate their region down there. So it's becoming, awareness is helping. It's making sure prevent that skin contact, safe disposal of these rags you're using. And can you use contactless methods as well? Do you need to be using a rag and soaking up that oil and then getting that oil all over your skin? Can you wear gloves? Can you use lances? Not touch it at all. There's ways around it. And because of health and safety professionals like yourself, because of
Yes.
occupational hygienists as myself, we are making it better and better and preventing things like that from happening.
Okay. Okay. Does anybody want to ask Mary directly a question from those on the call? If you want to just put your hand up and I'll see you. And if you want to, or come off mute and just ask away. Completely up to you.
I don't mind either way. I have to put the kids to bed in a minute, so
don't worry. Don't worry.
Don't worry.
I saw a note from Rabindranath who said that he did some work for a welding fabrication company. Do you have any questions for Mary in relation to the work you do with your welding and fabrication company?
Oh, hi. Good evening, everyone.
Hello.
Yeah. No, we did a risk assessment with similar control methods that what Mary is saying there.
Yes.
However, sometimes the guys don't want to wear the respirators and stuff, and they are exposed to the fumes. So I'm glad I'm in this webinar with you guys.
Okay. Are you in the UK or from?
No, I'm from Trinidad and
Okay.
Tobago in the West Indies.
Even better. It's probably a lot warmer there than it is here.
Yes, it is. Very warm.
So good. I mean, that's excellent. I mean, and do you find the what Mary's gone through tonight useful? What you've seen, what you've learned?
Yes, I think this is very useful. We may have missed some of the things that Mary discussed, and I think we could be more objectives when we're doing our risk assessment now than more selective. So I think she really covered stuff there.
Okay, and what you'll find is once we finish the recording and we have a little bit more, we'll put we'll send you a link. If you put your email in the chat to me, then we'll give you a link directly to the recording and the slides, because probably you're not going to have, for you to find our website could be quite difficult from Trinidad and Tobago.
Yes.
All right. Okay. So thank you very much. Okay, we've got another question. Well, somebody's asked, does anybody know if IOSH have any guidance on this topic in addition to Mary's hints? I don't think so, Nick, but I'll certainly go back to IOSH and ask them. But I've seen, I mean, there's so much on the HC website on the subject. And also, Mary, if you can give us a link to the British Occupational Health Society, the Hygiene Society would be really useful, because that also gives our members more things to look at as well.
Of course. Yeah.
Okay. Also, we'd like to work with you potentially in the future for another relevant topic, which we can share with members and your members as well, if that's okay.
Of course, yeah. Call upon me anytime.
I will. You know me too well now. Okay, if I just share my screen again, the final bits. So thank you very much, everybody. Let me do my final bits of what we got here. Hold on. Okay, so again, I think it's been a great session. Thank you, Mary, for giving us such a really informative slide talk, etc. We look forward to seeing other people, seeing you at future meetings with us. At the end of the meeting, you'll get an email, a short email from us on a survey to tell us what you thought about the meeting tonight. Please, any questions, please come back to us. Stay safe and well connected. In addition, what shows there is all the North Wales branch website, the LinkedIn site we have. So if you're not already a member of IOSH North Wales on LinkedIn, please connect with us. We've got our branch email address. So any questions or any further information you need, please send that to us. We also have IOSH Customer Service Centre email, IOSH Twitter, and also any webinars you'll find through our network events website. And finally, thank you. Be safe. Look forward to seeing you again in IOSH North Wales. If anybody wants to stay on and talk about any other subject, please stay on. If not, I'd say thank you very much. Have a great evening, and I look forward to seeing you again. And I'll close the meeting. So if anybody wants to stay on to talk about either CPD, IPD, or just meet a quick chat with some of the team, the branch executive team, please stay on and we can have a chat. So people who want to go, goodbye, and see you in August.